Hi guys, this is Additional Mathematics Form 4, Textbook Chapter 9, Solution of Triangle Intensive Practice 9.1 question. So if you enjoy this video, kindly like, subscribe and leave us a comment. Now let's go straight to the first question. Here, diagram shows triangle ABC. You're given angle B, angle C, length of AC. You're supposed to calculate angle A, length of side small a and small c. So the first part is very simple. Small angle A here, we can just use total interior angle for triangles 180. So to find this angle, I'll take 180 minus 77 minus 39, I'll get 64. Okay, to find length of side A, remember we have to use sine rule, and sine rule works such that you need to have, let's say for example, A divided by the opposite angle big A, and then you can use B divided by opposite angle big B. Now just use any two. As long as you know two angle and one length of side, you can find one of the missing information, which is length of another side. So I want to find small a, and small a, if you divide by the opposite angle, is sine 64, right? And the ratio must equals to the length of side B, which is 40.5, divided by angle B, we write sine 77. Just use your calculator. 40.5 divide sine 77 times sine 64. You get your answer as 37.359. Yeah, but the textbook so happens to give all the answer correct to 3 decimal places, so I want to match my answer with the textbook answer, so I always use followed here 3 decimal places as well. But for exam purpose, actually 4 significant figure is good enough. Alright, now if I want to find small c, I divide by angle 39, sine 39. This is the same, 40.5 divided by sine 39. Now notice, sine 77. Notice the ratio is always the same, because we can actually extend this to c over sine c. It's going to be the same. Yeah. Now, if I multiply over, in this case, I will get 26.158 cm. Okay. So let's move on to question 2. Alright, question 2. Here we are given a triangle, right? Such that we are supposed to find length of BE, CE, and DE. Okay, number one, if you look at this triangle, this is a right angle triangle. BA, should I say ABE? It's a right angle triangle. So to find BE, very simple. 10 square, 6 square, square root. This is going to give us 8. Now, if this is 8, this is 10, has to be 6, right? Yeah, because they are actually should I say identical, yeah, congruent, yeah, you can just flip it over, they're actually the same. So CE is going to be 6 cm, yeah, don't have to calculate further because you can see they're identical. Now how about length of DE? Okay, for DE we use Pythagoras one more time, because maybe I draw this out for you over here, so you can see that this is a right angle triangle as well. This is BDE, this is 17, this is 8. DE will be just 17 square, 8 square, square root, which is 15. Okay, alright, that's part A. So part B, if you want to find angle EAB, which is here, you can use SOHCAHTOA. You can use sine, cos, or tangent. Any three will do. But for me, since I'm given 6 and 10, so I just use cos. Yeah, like I say, you can use sine, you can use tangent. So cos angle EAB will be 6 over 10. Use your calculator. Shift cos 6 over 10. I got 53.13. Okay, and to find BCE, now you can see since these two are equal length, yeah, they're isosceles, these two must be equal angle as well, since this is 6 and 6, right? So BCE is also 53.13. Okay, next, if you're finding angle BCD is over here, right? Since this is a straight line, we'll just take 180 minus 53.13, 126.87. Okay, simple. Alright, next I want to find angle ABD. Yeah, to find angle ABD will be this whole thing. Yeah, I think we need to find this angle and add up with this angle over here. Now we already know that this is 53.13, right? So maybe we just find this angle ABE first. This is ABE, yeah, ABE. So let's find angle ABE. Now ABE will be 180 minus 90 minus 53.13, which is 36.87. Now if I know this is 36.87, I just have to add with this angle here. And to find this angle, maybe I use cos again. Again, you can use sine, you can use tangent. I just use cos because I do 8 and 17 first, right? So cos angle DBE will be 8 over 17. DBE will give us 61.93. Now if I know this 61.93, we can add up with 36.87 to get angle DBA or ABD. ABD, they're the same. So angle ABD will be 61.93 plus 36.87, answer 98.80. Now take note that the answer given in the textbook is 81.20. I wonder how they get this answer. I've tested from different angle. If I find, even I've started by finding this angle, I still get 98.80. Okay, maybe there's a mistake. Now next I want to find CBD. CBD is this angle over here. Yeah, this angle over here, right? So too many lines, I just write this off. Yeah, so to find this angle, very simple. I just take the whole big angle DBA minus this angle over here, right? Or you can just focus on this triangle here. Yeah, this whole triangle, the whole angle minus this to get this. So I can take 61.93. Yeah, this whole thing is 61.93. Yeah, can you see angle DBE? You minus the small angle here, which is 36.87, and I got 25.06. all right. Okay, lastly, explain the ambiguous case in the diagram. Yeah, okay, now we know ambiguity happens when the opposite side of a given angle is shorter than another given side. So here we have two possible triangle. Ambiguity means the existence of two possible triangle with the same measurement. So let's focus on the first triangle, the big triangle, if you like, the big triangle. This is the first triangle, right? So for this triangle here, let me redraw for you. This is B, D, and this is A, right? The measurement is 10, 17, and you can see this angle is the same. Now we don't need to find this angle, yeah, not necessary. So but the second triangle, if you take this and you flip it inside, can you see there's another one that has the same angle here. Yeah, this is still D, this is B, this is C, and this is still 17, this is still 10, right? So we can say triangle ABD and triangle BCD, yeah, or CBD. Maybe I follow the same order, like CBD, ACD and ABD and CBD. Yeah? All right, they are ambiguous, because why? Angle BDA is the same as angle BDC. These two angles, they are equal, right? All right. Should I say, maybe I add in here, has the same angle, okay, and two equal sides, two sides with equal length. Should I say two sides with equal length? That sounds better. Two sides with equal length. So the length will be what? Just say that the first one is your BD. Now I know this sounds a bit weird because it's BD equals BD, they're both BD. Maybe you should say the second one is B prime, D prime, but they are actually the same, right? Now another one is your length AB equals to length BC, right? AB and BC, or should I say AB and CB? That's better because follow the same order, right? So AB and CB, we can put a prime there, yeah, because this length and this length, they're actually the same, right? Ambiguity happens when opposite side of a given angle here is shorter than another given side, can you see? And therefore we can have two possible triangles with the same measurement. Alright, so that's it for question number 2. Let's move on to question number 3. So in this question, we have an obtuse angle PQR, alright, obtuse angle PQR. So I draw this triangle like this, okay. Now they say obtuse triangle PQR. Actually, question never specified what is which one is the obtuse angle, but I just draw a possible triangle. This is 14, QR is 6/3. Now, one of the things you can do, like you're not sure which one is longer, which one is shorter, is you type in your calculator 6/3. That will give us 10.392. So I know that PR is the longer side. Yeah, the longer side, not necessarily the longer side. Yeah, but in this case, right, I think the textbook in a way trying to like tell you that this is your obtuse angle, right? Actually, it could be another one. You can have this as an obtuse angle. It's possible. I'm not discounting the fact that R can also be obtuse. They say state the obtuse angle and find the size. So the answer from textbook is based on this, because we can say that since 14 is the longer side, but we don't know whether PQ can be longer than PR. That's the question, right? So, but I don't want to go too far and list out all the other possibility. So I will just stick to this, right? So to state the obtuse angle and find the side, we know since PR is longer, or the longest here, right? So the corresponding angle PQR will be the obtuse angle. So we say we're supposed to find angle, so I can sine PQR, use sine ruler, divided by opposite length is 14, sine 40, opposite length, I'll just use the cert answer. The length insert form is actually more accurate. Now use your calculator. PQR in this case is 60, right? So but we can't write 60 here because since they already say, yeah, the obtuse angle. So the obtuse angle is, okay, should I explain here, since PR is the longer side, yeah, is greater than QR, so your obtuse angle is angle PQR, right? That'll be better to explain. And then angle PQR is 120, but that's your answer for A. Yeah, remember when you use sine, cos, tangent, yeah, there are two possible answer for sine, because okay, some of you probably haven't learned this yet. I think most of you haven't learned this yet, right? So when you solve for sine here, you will get, I think your answer is close to 0.866 something, yeah, around there. So there are two possibilities to get for sine, right? When you use your calculator, when you press shift sign, PQR, we call this a reference angle. You learn this in trigonometry from 5 mod maths and also at maths. You will get this will be 60 degree, okay? But this sign here can have two possible value. It can be 60. This angle here can be 60, can be also 120. That's because when you now I'm going to find explaining all these things, but we call this a unit circle. So let's say this angle is x and y, this coordinate is x and y. Sine is a ratio of opposite. Your opposite is y, your hypotenuse is 1. A unit circle has what do you call that, radius of 1. Sorry, my circle looks a bit ugly. Now there's another point on the coordinate that has the same y value, because when you find your sine, you're taking y divided by 1. So your y value is actually here. There's another y value over here that, yeah, has the same, I mean there's another point here that has the same y coordinate, but the angle is different. The angle is measured from here to here. So we call this a general angle. We call this small theta here the reference angle. And to find the second possible angle here, we need to take 180 minus. So remember, when you use sine rule, there are two values. It's either 60, or in this case 180 minus 60. That would be your obtuse angle. In quadrant 1 is called acute angle. In quadrant 2 is called obtuse angle. Yeah, I shouldn't go too far about this. Yeah, we should just stick to this 120. All right. Now next, I want to find length of PQ. So I have to use sine rule again. So take PQ, divide by this angle. Okay, the problem is I don't have this angle. I know this angle over here is 120. So 180 minus 120 minus 40. Maybe I list out for you lah. Write this down for you first. This angle BRQ will be 180 minus 40 minus 120, which gives us 20. And once I know this is 20, I can use sine rule one more time. PQ divided by sine 20, 14 divided by sine 120. Now use your calculator. 5.529. Okay, so let's continue with question number 4. Alright, let's move this up. Okay, for question number 4, diagram shows a square fixture frame which is hung by Amira using 2 pieces of rope. Right, Amira finds that picture frame inclined towards the right. So I think you can see from here that I think I just zoom in like this, easier to see. Don't have to redraw triangle for you. This length of one side is 20, another one is 15. So the longer one will be 20 here, shorter one will be 15 over here. Alright, I need to find the perimeter. To find the perimeter of the frame, we need to find the length of this side. So let's call this length as x. Okay, so we can use sine rule. Now the problem is I don't know this angle, right? So I'm going to call this angle theta. Remember, to use sine rule, you need to have a pair of angle with the opposite length. So in this case, sine theta divided by 20, and the other pair will be sine 48 divided by 15. Now use your calculator. Sine 48 divided 15 times 20, and straight away sine inverse. Yeah, I hope I don't have to write so many steps for you. You can do this one shot. Yeah, as in you get, if you want, I can just write this down for you. Sine theta equals to, you type sine 48 divided by 15 times 20. Yeah, okay, I got 0.9986. Now actually you don't have to write this. Don't have to write this straight away. 889 straight away. Use your calculator. Shift sign, answer 82.25. Okay, 82.25. So once I know this angle, I can find this angle. I'm gonna call this angle alpha. So to find alpha, we take 180 minus 82.25 minus 48. I got 49.75. Now it's important that you find this angle so that you can find the opposite length x. Okay, so I know now that this is 49.75. Let me write down. Okay, drop all this off. This is now 49.75. I think I'll still write this down for you. This is 82.25. Okay, so we'll take x divided by sine 49.75, and the result must equal to 15 divided by sine 48. Now you can use other ratio. You can use 20 divided sine 82.25, but it's better to use the original value, just in case you make mistake in your calculation earlier. It doesn't affect the final answer. So your x is now 15.405. Okay, now I'm not done yet. I need to find perimeter. Perimeter is the length of all 4 sides. So you take 4 times 15.405. I got 61.62 cm. So that's the perimeter of the frame. All right, moving on to question number 5. Okay, so this one related to position of a house, house using sine rule. Now here we have upon Aziza's house, the houses of the two children, Amir and Anita. So Amir is, I'm going to put M because they all start with letter A, right? So Aziza, Amir, Anita, oh, kids are all letter A. So Anita, I put N, second letter. Aziza, I put Z. Okay, they say that another child, Ida, wants to build her house such that all three houses of the sibling are collinear. Collinear means what? They must be on the same line here, right? Okay, so and the distance of her house and Anita's house to Aziza's house is the same. So that means Anita, can't use A, they say distance from her house, Ida put I, Ida to Aziza's house and Anita's house to Aziza's house. So that means Ida to Aziza and Anita to Aziza must be the same. So now in order for it to be the same, these two must be equal, right? Ida, I put I lah, can write here Ida. Okay, now and notice this is 120, so this is 60, and if this is 60, this is also 60, and this is also 60. So it's actually an equilateral triangle, right? So we are supposed to find distance between Anita and Ida's house. We're finding this length, and to find this length, we can actually find Aziza to Anita's house because they're the same. Right? They're all three equal length, right? So I think we just focus on this triangle here. Let me highlight this triangle here. Just focus on this triangle here. All right. I want to find the length of ZN or NZ. Okay. So we use sine rule, but I don't know this angle here, right? I don't know this angle. So I need to find this angle first. Okay, so maybe I find alpha first because alpha is opposite to 150, 120 is opposite to 250, right? Okay, so yeah, we'll find sine theta alpha divided by 150. The ratio must be the same as sine 120 divided by 250. Okay, so from here, use your calculator, find alpha. My alpha is 31.31. Okay, now next I want to find Aziza's house to Anita's house. So I use Zn, Ziza Nita, Nita, divide by sine. I need to find theta. Well, theta, let me write down theta first. Theta will be 180 minus 120 minus 31.31. So this will give us 28.69. Okay, I can just map it on the diagram for you to see. Since I know this angle is 31.31, 180 minus 31.31 minus 120, so this is 28.69. So Zn, Aziza, Anita, divided by sine 28.69 equals to, let me use 250 divided by sine 120. Okay, right? 250 divided by sine 120 here. Now, what would you get? 138.58 meter. Okay, because triangle ZNI is equilateral, right? We can see from here they're all 60. So length of NI must be the same as Zn, must be the same as Zi, right? So you're finding the distance between Anita and Ida, so which is Ni. Okay, so should I just write Ni here? Distance Ni must be the same as Zn, 138.58 meter. All right. Okay, that's the end for this practice. So again, if you are interested in our more, to find out more, we have like lots of books that are written and prepared to help students to understand the subject MS better. So you can actually find out more from our Shopee account. You can go to our Shopee account here. Can you see? Yeah, you can order the books, or you can find some of our books through our website, or get in touch with us. Yeah, WhatsApp, call us. Yeah, and or form our social media account. Thank you very much for watching. Yeah, I hope to see you in the next video.